Hello everyone, my name's Dane. In this video we're talking about failure modes, why they're important and why they're considered to be the currency of great asset management. So let's start at the top. For the purposes of this video, we're going to adopt a simple definition, which is a failure mode is a way in which something might fail. And understanding an asset at the failure mode level is where the best decisions are made, since the failure modes are critical to understanding how an asset can fail to perform its function. All right, so given that a failure mode is a way in which something might fail, how do we describe that way? Well, we typically use an adjective describing the state of the asset. Something like blocked, cracked, bald, or seized. Like chute is blocked, structure is cracked, the tire is bald, or the valve is seized, for example. Now, one thing to note is that this has no reference to the preceding causes, and it has no reference to the subsequent consequences or effects. And we'll cover these in just a bit. So you want to think of a failure mode as a picture or a snapshot in time where you can see the exact state of the asset, but you don't know how it happened or what led to that state and what the impacts were. All right, so how do we methodically determine what failure modes exist on an asset? There's already an existing process for doing this. It's called reliability centered maintenance, or RCM for short. And it uses kind of like a hierarchical approach to defining failure modes. So RCM says that we start with the components. We figure out what components are within the asset or the system that we're looking at. What are each of the components' function in that overall system? What are they designed to do, and what's the intent of them? And then we look at how each of those can fail to perform the intended function. What are the ways in which it will not meet the specs or the requirements in its application? And from there, we can start to understand what are the different modes or ways in which it can fail to perform its function and therefore fail as an asset in our system. And this is a really useful starting point. And both the FMEA and FMICA processes typically start with a similar structure. We're not going to get into FMEAs or FMICAs in this video. If you want me to do a deep dive on these topics, just let me know in the comments. The intent of these processes, that when I say these processes, FMEAs and FMICAs, so the failure modes and effects analysis and criticality analysis, is to really determine if we have the appropriate capital and maintenance strategies to address the modes that an asset might exhibit, and therefore reducing the actual failures that we see. All right, once we start venturing into the FMEA and FMICA land, we start to make causal links between failure modes and other things like effects and consequences. So let's look at it from a failure process point of view instead of a hierarchical point of view. And this is interesting because it shows some other common concepts and terminology that often come up in conversation when talking about failure modes. And so let's start with causation. Causation indicates that one event is the result of the occurrence of another event, i.e. there's a causal relationship between the two events. This is also referred to as cause and effect, and we represent the cause and effect relationship using an arrow, like in this diagram here. And for this arrow, the cause is the origin or the starting point of the arrow, in this case event 1, and the destination is the effect. Right, we use an arrow because the causal relationship is directional. It's one way. And here's an example. So we have one event when the sun rises in the morning, and a second event, the rooster crowing. If you were to analyze both of those events, there would be a high correlation between the two events, because every time you see the sunrise, the rooster would crow. But it's actually not just a correlation, it's causation. It's directional and it's one way. So the sun rising is causing the rooster to crow. And we know it's one way because if we were to remove the rooster from the equation, if it, passed away, for example, the sun would still rise. So the sun rising is not related in any way if the rooster is there or not. But considering it from the other direction, if we remove the sun, the rooster may not crow. So we can say, using this kind of diagram here, the sun rising causes the rooster to crow. And this is similar to how you'd map out a causal diagram in, let's say, some root cause analysis example by mapping causes and effects. And it's pretty intuitive. This is how our brains are wired to think. We can map failure modes the same way. All right, so let's start with a single failure mode. In this case, we're going to say the failure mode is the asset is cracked. And we can look forward, kind of like you're looking forward in time, to the effects of that mode's occurrence. All right, so the evidence of a cracked failure mode causes the component itself to fail, which then causes in turn the asset as a whole to fail, which then usually causes some sort of flow-on effects and consequences in business impacts, which then may cause some secondary actions or corrective work or reactive work to take place to rectify the failure, and so on and so on. So in this case, there is no one cause. Everything to the left of the reference frame you're looking at is causing everything to the right. And if you think about it in terms of those arrows, like I just said, the cracked failure mode causes the failed unit, which is the component, which is the effect. But that effect is also a cause of the next thing in line, which is the complete asset failure, which also causes the flow-on effects and consequences. So perhaps effects here is a bad word to use, or not very clear. What I mean by this is effects in terms of the way Famika and Famia define effects, but in terms of cause and effect and causal relationships, each point at the start of the arrow is a cause, and each destination or end point of the arrow is an effect. All right, so let's look at everything to the left of the failure mode. This is typically what you would think as being causes of that failure mode, because they're to the left of it. And we can kind of break this down a little bit more. Let's do it similar to an RCA would, and let's start with some conditions over to the left. So some conditions that currently exist. Let's say we've got some vibration in the environment, maybe through attached steel structures and things like that. Let's say that there is no support or additional support for the asset. It's just bolted to that vibrating structure. And let's say it's made of some sort of brittle material. Okay, these are preconditions, but these also are causes to the failure mechanism that evolves or develops from that. So the failure mechanism for this, in this case, let's call it micro cracking for the sake of the argument. And then the micro cracking over time causes a substantial defect, which then causes the evidence of that failure mode that we're looking at, the cracked failure mode. So we can see that a failure mode, just like other events, can have multiple causes. And similar to RCAs, if you eliminate, or root cause analysis, if you eliminate any of the causes over to the left, you should, in theory, eliminate the end effect. So as a bit of an aside, I'd encourage everyone to write down your failure mode and cause statements instead of writing something like the component is cracked due to vibration, where it's component failure mode due to cause. You instead expand that cause to all the potential causes on the left. Usually just the very extreme or end current conditions. And if for nothing else, it's just to articulate a bit of a more complex picture and for identifying opportunities for improvement. So in this case, if we took something like vibration causes the cracking, we may miss out on some improvement opportunities like adding in supports or changing the material types and things like that. So you start to see a bit of a merging between root cause analysis thinking and reliability centered maintenance or Famia and Famika approaches. All right, connecting everything we've just talked about together, we see an end-to-end picture that looks something like this. it can be treated similar to like a bow tie diagram, especially if you have multiple effects and consequences over on the right. So the next question is, why is it good practice to treat the failure modes as being central? Well, because we can just as easily use other reference frames like focus on the effects. But then typically what happens is if you keep following it down to the right, you're performing a corrective task to address the failure event, which addresses one or more failure modes. So it circles back to the failure modes. And even things like inspections and condition monitoring are looking for defects and evidence of failure modes. And even when we're analyzing our assets, looking at likelihoods of failures occurring, we're developing probability distributions that sit at a failure mode or failure mode and cause level. So all the roads keep leading back to the failure modes, and having failure modes central to our discussions is how we can make the connections to planning teams, to risk management teams, and to maintenance teams. That's it for this video. I hope you got something out of it. If you did, crack the like button, impact the subscribe button, and let me know in the comments if you want to see any other topics of interest. Have a great rest of your day.